Okay, so in today's video, we will see how to solve the problem of by using the simplex method. Okay. Question is like solve the following NP problem using simplex method. So this is the problem statement, and the problem that we have to find the solution for is the objective function is maximize z equal to 3x1 plus 2x2, right? This is the objective function and it is subjected to constraints x1 plus x2 is then equal to 4, x1 minus x2 is then equal to 2, and non-negativity constraint x1 x2 is then equal to 0. Okay, now let's find the solution. In order to find the solution, the first step that we need to do is we need to change the objective function and the constraint equation, right, into the standard form. So for that, and it maximize z is equal to 3x1 plus 2x2, and we have to change the constraint equation into the equalities equations. Sorry. So for that, we need to add our subtractive variables as per the condition. So if it's less than equal to sign, that means we have to add the slash variable. So x1 plus x2 plus s1 is equal to 4. I'll write 0 s1 over here, so that we have added the variable, but the constant is 0. So when we multiply it, we'll get a 0, which means that there will be no effect on the objective function. And the second one is x1 minus x2. So I have plus 2 is equal to 2. So again, we have added the variable s2. S2. That means the value of s2 variable is 0 over here. And over 1, the value of s1 is 0. So this is my standard form of, and I have 4 variables now, x1, x2, s1, and s2. So then equal to non. Right? Now I'll write this equation into the matrix form, and the matrix form is that I'll write the constraint equation. So 1, 1, 1, 0. Then I have 1, minus 1, 0, and 1. Then we have 4 variables, x1, x2, s1, s2, and the value is 4 and 2. Now, what I need to do after this is I need to convert the initial to start with the iteration, and for that, what we need is we need the first table. Right? So I'll change the page because I don't have much space away. I will start from a fresh page so that we can get the iterations going on. So I'll just change the page. Okay. So start from there. Now, in order to start this problem, start on again. So I'll draw the table first, and then we shall start with the iteration. The first column in the table is always of the first column that we have is of basic variable. So first column is basic variable. Now, initially, the variables which form an identity matrix, that is, the diagonals are 1 and the remaining elements is 0. They come into this. Then we have the coefficients for those variables in the objective function. Then we have the solution. XB is the solution. That means right hand side of the constraint equations that we have. Then here we have the table. We have variables x1 and x2. Then we have s1, s2. Then we have a cost and the minimum ratio. So the ratio of x, that is the solution, by xj. The entering variable which we select, right? So here we have Cj, that's coefficient in the objective function. So the objective coefficient of x1 is 3, coefficient of x2 is 2, s1 is 0, and s2 is 0, right? Let's come. So basic variables initially will be s1 and s2, right? So the coefficient of s1 is 0, and the coefficient of s2 is also 0. And I'll copy this over here. So 1, 1, 1, 1 minus 1. It is into 4 plus 0 into 2 will not equal to 0. Now, the third step, what we do is the condition of optimality, which is Cj minus Zj. If Cj minus Zj is negative, then we have an optimal solution. Otherwise, we have to replace it. So Cj minus Zj, 3, 2, 0, 0. Over here, we have two values. So we'll take the maximum value. That means x1 is the variable which will enter. So xp by xj is, this is 4 divided by 1, which is 4. And this is 2 divided by 1, which is 2. Now the minimum value is 2. That means S2 will move out, and in place of S2, what we'll have? We will have X1. Okay. So in the next table, what we do is we have to iterate it. So this is our key element. We have to make the key element 1. It is 1, so we can write it as it is. The first variable remains same. We won't change the sequence of the variables. S1 remains S1. S2 has gone out, and instead of X2, we have X1. So we have X1 over here now. Okay. Now, if they would have to ask X1, that means we can write the entire C, that is the coefficient or constant for X1 is 3. 3. Now 2 remains 2 because we have 1 over here. One minus 1, 0, and there's no change in the row. Now we have to make 0. So 1 corresponding to element of iteration. We have to apply something which 1 tends to R1 minus R. Only then it can be 0. Minus will give me 2. It remains 0. Right? 1 gives me 1 minus 0, 1. And 0 minus 1. That is C. 0 into 2 plus 3 into 2. That gives me 6. Now we'll calculate the value of Zj. 0 will again give me 0. I'll just multiply by 3. So this is 3. This minus 3. Okay. This is 3. So let's go with Cj minus Zj, the condition of optimality. 3 minus 3 gives me 0. 2 minus minus 3. 2 plus 3 gives me 5. Right? 2 plus 3 gives me 5. This value remains 0 and this value comes out to be minus 3. Right? So we have another positive value, that means we have to go for the iteration. So now what will happen? These are selected. That means the entering variable is x2 and we have to find out the leaving variable. So finding out the leaving variable, again we have to do xp by xj. So xp is 2 by 2 is 1 and this is minus, so we don't have a value. So only this is. So in place of s1, what do we have? No, s1 will move out and in place of s1, s2 will move in. So we have x2 and we have x1. So we'll write the coefficients of x2 and x1 first. The coefficient of x2 is 2. The coefficient of x1 is 3. Right? Now, let's come to the key element. So key element over here is 2. This is the key element. So first we have to make 2 to make 1. This key element should be 1 and the corresponding element in the column should be 0. So for that, I have to apply an iteration that R1 tends to R1 divided by 2. So all the variables x, they have to be divided by 2. So 2 divided by 2 gives me 1. 0 by 2, leave it, 0. 2 by 2, 1. 1 by 2 and minus 1 by. So this is the value which I have in the first two. The second value that I have to make this value of minus 1 as 0. So I have to put in a function R2 tends to R2 plus R1. If we add plus 1 and minus 1, that will be 0, right? So let's add. So when we add this, what will happen? 2 plus 1 will give me 3. 1 plus 0 will give me 1. Minus 1 plus 1 will give me 0. 0 plus 1 by 2 will give me plus 1 by 2. And 1 minus 1 minus 1 by 2. That will be 1 by 2. Okay. Let's find out what is 2 plus 9. 2 plus 9 is 11. So the value of z is 11. Right? So value of z comes up to be 11. And let's find out the value of zj. So zj is 2 into 0. 2 into 0, 0 plus 3 into 1, 3. 2 into 1 plus 3 into 2. So 2 into half will give me 1. 3 by 2. So 1 plus this is 1 plus 3 by 2. 5 by 2. 3 by 2, yeah, 5 by 2. Then I have minus 1 and minus 1 plus 3 by 2. This is 1 by 2. 1 by 2. So let's find out CGA minus ZJ. If all the values are negative or zero, that means we have an optimal solution. Otherwise, we have to go with the equations again. So let's see. CJ minus ZJ, 3 minus 3 is 0. 2 minus 2 is 0. This is minus 5 by 2. And this is minus 1 by 2. Since all the values are either of Cj minus Jj, it is either 0 or negative, that means we have an optimal solution. And the optimum value is z is equal to 11 at x1 is equal to 3 and x2 is equal to 1. So we have a solution right now for which these are the values. Right? So this is how we again solve the question of a simplex. Okay, so in today's video, we will just solve one more number. And this is important because what happens when we have options of selecting any one of the two um, points leaving the variables, and when there's a tie between two leaving the variables. And moreover, to check the quantity, whether what we are doing is optimal or not, and what happens if we keep on, optimal. So just let me. That is just the question we have taken for the specific cases. Maximize the z is equal to 5x1 plus 3x2. Okay, that is the value. And this is the two constraints. X1 plus x2 is equal to 2. Then we have in constraint 5x1 plus 2x is equal to 10. We have 3x1, 8x2 less than equal to a non-negative one. The first step is that we need to see the objective function is of maximizing time. So this is done. Then the right hand side of the constraint equation should be positive. Again, this is done. First step is that we need to convert this problem into the standard form. I write the standard form over here. What I need to do is I need to set the okay. So I'll write it here. And z equal to 5x1 3x2. This is the original one. Now we need to change the constraint equation. Right? X was less than equal to, so we'll add a variable stack s1 over here. This is the value of equation 4. And I'll write the second equation 5x1 2x2 plus s2 is equal to 10. Third equation will be 3x1 plus 8x2 plus s3 is equal to standard form. I have to add the basic variables above also in the constraint or in the objective. 0s1 0s1 plus 0 s2. So this is this is what my objective function equation looks like. Right. So that is the standard form. Now I need to convert this into an equation or matrix form. Ax is equal to b. Again, I will not write that step. I'm skipping that step. I'm directly coming to the table and then right. We'll put that in table form. So the first column is a second column is two values CV, coefficient of these basic variables, and XD is the right hand side of the constraint solution method. Right? We write CJ, coefficient of these variables, X1, X2, S1, S2. Then here we have a column for minimum ratio XB, that is solution by variable. So initially, for the basic variable, we take the variables from the identity matrix. So if you look over here, S1, S2, and S3, these are the variables. Because S2 component will be 0, S3 will be 0, then here S1 will be 0, S3 will be 0. And in the last row, S1 and S2 will be 0. Right? So the basic variable at the first time, S1, S2, and S3. These are the basic. The coefficient of the basic variable S1 is 0, S2 is 0, S3 is again 0. Next is solution of the constraint equation is 2, 10, 2. Right hand side of the constraint. Okay, so that is done. Now we have x1. X1 coefficient is 1, 1, 1, 0. Similarly, for this equation, 5, 2, 0. The last one is 3, 8, 0, 1. Over here you can see that S1, S2, S3. That is the reason why they are only basic variable from the first step. Okay. Next, we calculate set 0 multiplied by 2 plus 0 multiplied by 10 plus 0 multiplied by 12 is 0. So Z is 0 at the first instance, right? Come to ZJ again. ZJ will be 0 because coefficients are 0. Condition of optimality Cj minus ZJ. If 5, 3, 0, 0, 0. These are the CJs, right? Coefficients of the variables, the objective function. Cj 5, 3, 0, 0, 0. 5 is positive, so this will be 5. X1 is the entering variable, and some variable has to leave. For that, we have xb by xj. 2 divided by 1 gives me 2. Then 10 divided by 5 gives me 2. Then 12 divided by 3 gives me 4. So over here, we have a tie between x1, s1, and s2. There are two variables which can leave. Either we can make s1 leave or we can make s2. Now, I will show you both the types. I'll solve this question for both the. So that uh, what I have over here is I have time. Let's say that the first case, let's say that S1 will leave. So S1 leaves, and this one is a key element. And we know that we have to make key element 1 and all the other elements 0. Okay. So let's start with that. The first step. So line over here. This is the line, and then start it. Okay. So the second one is that we don't have x1 anymore. We will have x1 over here, x1, and we have s2, we have s3. The value of x1 is the coefficient of x1 is 5. Right, 5 over here. So this because the key element is 1, we do not have to make any transformation in the row. So all the values of variables will come down as will remain 2, 1, 1, 1, 0. Let's come to S2. This value is 5. So we have to reduce this 5. 0. We have to reduce this 5 into 0. The only way of doing that is by using the transformation of R2 tends to R2 minus 5 times R1. Because we have made this as 1 and now we have to subtract it by 1. So that is the case. So now let's do that. So see, first is 10. 10 minus 5 into 2, 10. That will give me a 0. 5 minus 1 into 5, 0. And 2 minus 5. That will give me a minus. Over here, we'll have minus 3. So the next one is 0 minus 5. We have minus 5 over here. Then 1 minus 0. Then 1, 0 minus 0. 0. That is the first transformation. And then we have row third. So we have to make this clear. R3 to R3 minus 3 times R1. Right? So we have 12. 12 minus 3 into 2, 6. That gives me a value of second is 3 minus 3. That will give me a 0. 8 minus 3 will give me a 5. Then 0 minus 3. Then minus 3. Then we have 0 minus 0. 1 minus 0. So that is the equation. Now let's find out z. So z at this instance is 5 to the 10. Z. Okay. So we have moved from 0 to 10. Now let's find out zj. Zj is only 5 will have because we have 5. We will have 5. Over here, we will have 5. Over here, we will have 5. 0 and 0. Cj minus zj, condition of optimality. So 5 is 0. 3 minus 5 is minus 2. 0 minus 5 is minus 5. 0, 0. So over here, we can see that the condition of optimality is satisfied. All the values are either negative or 0. That means we have reached the optimal solution. The optimal solution is that z is 10 at x1 is equal to 5 and x2 is equal to 0. We do not have the value of x2 in this table, that means x2 has to be 0. Right? So this was the first case in which we have taken s1 as the leading variable. Now, if we do not take s1 as the leading variable, what will happen? If we by mistake take s2 as the leading variable, so for that, I'll create the table again. I won't write the entire question again. I'll create the table, and from there we'll start to solve. Okay, and then write it down. Okay, so start from table, and so I'll create the table, and then we shall see where to create the table. So we have the first column of basic variable. Initially, the variables will be s1, s2, and s. We have coefficients of these variables in the objective function 0, 0, 0. Then we have xb solution. That is the right hand side of the constraint. Is 2, 10, and 12. Then we have x1, we have x2, s1, we have s2, s2. Then we have a column for xb by xj minimum Then we have coefficient Cj, which are 5, 3, 0, 0, 0. And we have the table 1, 5, 3, 1, 2, 8, 1, 0, 0, 0, 1, 0. So that is the table. Now, first instant Z was 0. Zj were again all 0. Cj minus Zj and 5, 3. Select 5. These are entering variables. Then we have 2 by 1. Then we have 10 by 5, which is again 2. And we have 12 by 3, which is 4. So in the first case, what we have done is we have taken S1 as the leading variable. Now let's select S2 as the leading variable. For the sake of understanding, I'm doing this step so that we can understand what happens if we choose different variables. Will we get the same answer or the answer will vary? Right? Now, let's go back. Okay, so first table is done. Now let's say that we have chosen S2. So the first variable remains the same. We have S1 over here. We have coefficient 0. Okay. Now, the 5 is the key element. We have to make this 5 as 1. And then we have to make the other element 1 and 3 as 0. So I won't write the value of xb and write x1. Then x2 in case of x2 we have x1 and the coefficient of x1 is 5. And after x1 we have s3. We have s3 over here. And the coefficient of x3 is 0. Now, okay, in order to make 5 as 1, we'll use the transformation of R2 tends to R2 divided by 5 only, then we can make the 5 as 1. 10 divided by 5 is 11. 5 divided by 5 is the value of 1. Then I have 2 by 5. We have a 0. We have 1 by 5. We have 0. That is the value of the second row. R2 to R2 divided by 5. So let's come to the first row. So for first row, we have is 1. In order to make this 1 as 0, what I have to do is I have to use the transformation R1 into R1 minus R. Right? So the first XB, that is a variable. So 2 minus 2 will give me a 0. This is a 0. Now, 1 minus 1 will give me a 0. That is fine. Then 1 minus 2 by 5 leaves me with a value of 3 by 5. I have the value of 3 by 5. And 1, 0, give me a value of 1. 0 minus 1 by 5. So that gives me a value of minus 1 by 5. And we have 0 minus 0. 0. So that is the first row. The third row, what we have is we have 3 as the value. So I'll use the transform R3 times R3 minus 3 times R3. पहले 1 को 3 बनाएंगे फिर 3 से स्टार्ट करेंगे. तो ये कितना रहेगा 12 minus 6. Give me a value of 6. Then I have a value of 0. Then 8 minus 8 minus 6 by 5. It has a 34 by 5. 34 by 5. इसके बाद ये वैल्यू रहती है 0. ये रहता है 0 minus 3 by 5. Okay. By 5. ये रहती है 1 minus 0. So that is the value that we have for this. Let's again calculate Z. Z देखिए कितना गया इसका 5 to the 10. Second में फिर से 10 आ गया. कैलकुलेट सेट जे। जेड जे देखिए कितना हो गया, फिर 5 वाला आएगा तो 5, देन वी हैव 5 बाय 2, 5 बाय 5 2, ये हो जाएगा 0, हो जाएगा 1, ये हो जाएगा 0। सीजे माइनस जेड जे, 5 माइनस 5 0, 3 माइनस 2 1, 0 minus 1 0. Now we have x2 as the entering variable, क्योंकि ये वैल्यू पॉजिटिव है। अगर वैल्यू नेगेटिव होती तो हम ऑप्टिमल सोल्यूशन में पहुंचे होते, लेकिन क्योंकि ये वैल्यू 0 नहीं, तो we have to iterate again. Now, let's see something interesting over here. So let's calculate. Okay, let's go for the iteration. Now going for the iteration, we know that this value will leave. तो यहाँ पे देखते हैं तो 0 वाला है तो ये मिनिमम रेशियो नेगेट हो जाएगा 0 बाय 2/5, ये हो गया 5, और ये हो गया, देखिए ये वाला ये हो गया 5 6 30/34, वैल्यू 30/34, that is something 34/34 is 1, 30/34 approximately 0.7 या 0.8 के आसपास। So obviously this is lower than the value 5, so this one is leading. This is our key element, 34/5, the key element. So let's go for the third, second iteration. So the values that I have, S1 remains, then I have X1, and instead of S, it will be X. Coefficient of S1 is 0, coefficient of X1 is 5, and coefficient of X2 is 34/5, so I need to make it 1. And the only way of doing that is to use the transformation that R3 tends to, okay, R3 divided by 34/5 या फिर multiplied by 5/30, one same thing. तो ये करते हैं, 6 multiplied by 5/34 will give me a value of 30/34. ठीक है, 0 means 0, ठीक है, ये 1 हो जाएगा, ये था 1 के आगे ये 0 हो जाएगा, ये कितना हो जाएगा, देखिए हो जाएगा 3 बाय -3, 5 कैंसिल हो जाएगा, -3/34 हो जाएगा, 3/34, लास्ट वाला हो जाएगा 5/1, 5/4. Let's come to the second row. We have to make this 3/5 as first row. 3/5 as 0. तो हमें ये करना है, हमें ट्रांसफॉर्मेशन लगानी है R1 and R1 minus 3/5 of R3. ये करते हैं, ऊपर क्या है 0, तो 0 minus 3/5 of 3/34, 3/5 हो गया, 5 6 कट हो गया, 6 3 बचा, ठीक है, ये हो गया 18/34 माइनस 18/34। यहाँ आते हैं, ये 0 है, नीचे भी 0 है, तो ये 0 ही रहेगा। ये 3/5 को करने के लिए 0 के तो ये 0 हो जाएगा, 1 है, नीचे 0 है, तो ये 1 ही रहेगा। आगे आते हैं, ये -1/5 है, ठीक है, -1/5 into 3/5, okay? तो into हो जाएगा 3/34, तो ये हो जाएगा -1/5 कॉमन ले लेते हैं और ये हो जाएगा 5 कट जाएगा, हो जाएगा -5/34। लास्ट वाले पे आते हैं, ये है 0 0 माइनस 3/5 5/34, 5 कैंसिल हो जाएगा, तो फिर -3/, हमारा आ गया। सेकेंड रो पे आते हैं, सेकेंड रो पे ट्रांसफॉर्मेशन लगाना पड़ेगा, R2 टेंड्स टू 2/5, R2 माइनस 2/5 इंटू R2, तो इसमें देखते हैं, देखिए ये है 2 माइनस 2/5 इंटू 3/34, कैंसिल हो जाएगा, क्या आएगा, 28/17 हो जाएगा 1, ये बन जाएगा 0, ये 0 था, ये 0 था, तो ये 0 रहेगा, 5 इंटू 3/34, तो ये कट जाएगा, क्या हो जाएगा, ये 4/17 वाला है, 0 जो 1 34 2 5 5 5 5 1/17, -1/17 आ गया, तो ये हमारा, हाँ, तो लेट्स कैलकुलेट द वैल्यू z, z इज इक्वल टू 5 into 28 140/17, ये हो गया हमारा 8 into 5 140/17 plus 3 into 50 90/34, तो ये 5/17 हो जाएगा, तो कितना हो गया देखिए, 185/17, 185/17, that is the value of z, is 1, कैलकुलेट लेट, तो 5 रहेगा, यहाँ पे 3 आ जाएगा, दोनों 0 है तो फर्क नहीं पड़ेगा, तो देखते हैं देखिए कितना जाएगा, ये जाएगा 5 4 20/17, ये जाएगा 17 माइनस 9/34, तो 34 को 40 माइनस 9 31/34 हो जाएगा, 31/34, और लास्ट में देखिए कितना हो जाएगा, ये देखिए -5/17 हो जाएगा आपका, -5/17 और प्लस 15/34 हो जाएगा, देखिए 34 कर लो तो 15/4 माइनस 10, तो ये 5/34 हो जाता है, जाएगा 5 by 54. Now let's come to the Cj minus Zj. Cj minus Zj. Uh, 0, 0, that is 0, negative, and this is negative. So since all these values are positive, therefore, 17. So we have this value. Now, so we have Z is equal to 185 by 17. So if you look at the value of 185 by 17, we have approximately 185 by 17, which is nearly equal to 10.8. 10.8. Okay. At x1 is equal to x value 28 by 70, and x2 is equal to 30 by 54. Now, if you calculate the value 8 by 17, that is approximately 1.64. If you round it off, it will come as 2. Okay. और नीचे वाली वैल्यू इट इज अप्रोक्सीमेटली 0.7. ठीक है, तो अब इसको अगर ऊपर की तरफ राउंड ऑफ करो, दूसरे को नीचे की तरफ राउंड ऑफ करेंगे, तो अप्रोक्सीमेटली की वैल्यू तो उसके बराबर ही है. देन स्लाइट डिफरेंस बिटवीन दीस. ठीक है, so that is the slight variation which can happen, but again if you look at the overall answer, it is nearly 10.8. मतलब ज़्यादा इसमें ज़्यादा डिफरेंस नहीं है, and optimality थोड़ी सी इंक्रीज हुई, but that is how it goes. ठीक है, that will be all.